Johannes Hevelius placed the modest lizard where there was no room for other figures. An ancient myth says a young man was turned into this reptile for mocking a goddess. But the main secret is hidden deep. Here lies the core of an active galaxy. This supermassive black hole is shooting a powerful beam of energy directly towards our planet.
Welcome. Today, our inquiry takes us to a seemingly quiet and unassuming patch of the celestial sphere, the constellation Lacerta, the lizard. Now, it may lack the mythological grandeur of Orion or the sheer navigational utility of Ursa Major, but within its faint boundaries lie astrophysical phenomena that have fundamentally altered our understanding of the cosmos. Let's begin our examination.
What's so compelling about Lacerta is that it isn't a relic of ancient mythology. It's a modern construct, born from a need for cartographic completeness and a dash of scientific wit. In many ways, it represents the triumph of laconicism, of precise scientific observation over grand narrative invention. It marks a shift from seeing stories in the stars to seeing data.
Our analysis will proceed through 5 sections. First, we will establish Lacerta's basic astrometric profile. Then, we'll delve into the remarkable astrophysical treasures it contains. From there, we'll investigate its unique history, touch upon an associated myth, and conclude with a practical summary for any observers among you.
So, let's begin with the fundamentals. Before we can appreciate what's inside the constellation, we must first define its boundaries and its overall presence in the night sky.
Lacerta occupies an area of just over 200 square degrees. To put that into perspective, it's a relatively small parcel of celestial territory, far from the sprawling giants like Hydra or Virgo.
In fact, this modest area places it 68th in size among the 88 officially recognized constellations, so we're dealing with one of the minor players in terms of sheer angular diameter.
And in terms of its stellar population, it's quite faint. Under ideal dark sky conditions, a mere 63 of its stars are visible to the unaided eye. This inherent faintness is a primary reason it was not delineated by ancient astronomers.
Despite its faintness, however, its visibility is quite extensive. As this global projection shows, anyone located north of latitude 33 degrees south, which includes all of the northern hemisphere and a significant portion of the southern, can view the constellation in its entirety. It is a constant, if subtle, presence in the northern night sky.
All right, so we've established its place on the celestial map. Now we transition from astronomy to astrophysics, from where it is to what is in it. And this, right here, is where this unassuming constellation becomes truly significant.
Its brightest star, Alpha Lacertae, is an A1V-class star, a standard white main sequence star situated about 102 light-years from Earth. It serves as the primary anchor for the simple zigzag asterism that gives the lizard its characteristic, albeit faint, shape.
But the true gem of this constellation is an object designated BL Lacertae. You see, for decades, it was cataloged as a mundane variable star within our own Milky Way. Then, in 1968, a paradigm shift occurred. Astronomers realized this was not a star at all, but the intensely luminous core of a very distant galaxy. This single observation gave birth to an entirely new classification of celestial object.
That object is a blazar. To understand this, I want you to visualize traveling 900 million light-years toward that single point of light. What you would find is a supermassive black hole, furiously accreting matter and firing out colossal jets of plasma at nearly the speed of light. And the key is, one of those jets is pointed almost directly at us. We are, quite literally, staring down the barrel of a cosmic particle accelerator.
As if that weren't enough, Lacerta also hosts one of the most bizarre exoplanets ever discovered, HAT-P1b. It's a hot Jupiter, a gas giant orbiting very close to its star. But what's truly anomalous is its density. It is so incredibly low, it's often compared to cork. Think about that. If a cosmic ocean existed large enough to contain it, this planet would float. So this begs the question, how did a constellation containing such profound astrophysical objects receive such a humble modern name? To answer that, we must turn to the 17th century astronomer Johannes Hevelius.
Hevelius wasn't drawing upon ancient lore. He was solving a cartographic problem. He was filling a gap in his star atlas between the larger, more established constellations like Cygnus and Cassiopeia. His justification for choosing a lizard, recorded in 1690, is a wonderful moment of scientific wit. He noted the area was so crowded, only something small like a lizard could be squeezed in.
His choice of name was even more clever.
He originally called it stellio, a type of spotted newt. But the name contains a beautiful pun. It sounds almost identical to the Latin word stella, meaning star. Hevelius had effectively created a star lizard to populate the heavens.
This simple, clever name, however, nearly didn't survive. It became a target for political flattery. Other astronomers attempted to rename it in honor of their patrons, proposing grandiose titles like Scepter and Hand of Justice for Louis XIV. But in the end, scientific pragmatism won out over royal ambition, and the simple, descriptive Lacerta endured.
Now, to be clear, Lacerta itself possesses no authentic classical mythology. However, a myth has been retroactively associated with this region of the sky, a cautionary tale from Greek lore about the perils of disrespecting the divine.
The myth tells of the goddess Demeter, who, while grieving the loss of her daughter Persephone, stops to quench her thirst. A young boy named Ascalabis mocks her for how greedily she drinks. This was a fatal error. In a moment of divine wrath, Demeter casts the remaining water upon him, and as the divine liquid touches his skin, he is transformed into a spotted lizard, a stellion.
This brings us to our final section, a practical guide for the observer. How does one actually locate these phenomena in the night sky? Though faint, Lacerta offers rewards for the patient viewer.
To locate Lacerta, find the apparently vacant patch of sky between the iconic W of Cassiopeia and the brilliant star Deneb in Cygnus. For those with binoculars, I recommend scanning the northern portion where it crosses the plane of the Milky Way. There you may resolve the faint, fuzzy patch of the open cluster NGC 7243. And for the dedicated astrophysicist, the real challenge: locate the coordinates for BL Lacertae. The visual itself is unimpressive, just a faint star-like point, but the intellectual realization that you are observing the core of a galaxy 900 million light-years away is profound.
So what is the overarching conclusion from our study of Lacerta? It serves as a powerful testament to a fundamental truth of cosmology. There are no insignificant regions of the universe. A patch of sky defined primarily by what it lacked, by its emptiness, has yielded one of the most extreme classes of objects known to science. And so this leaves us with a final, contemplative question. In an era of large-scale sky surveys and automated searches, Lacerta is a crucial reminder of the importance of careful, focused observation. It forces us to ask, what other universe-altering secrets lie waiting, not within the grand, bright nebulae, but hidden in plain sight, in the most modest corners of our sky?
Thank you, friends. Strive for understanding and become wiser. See you soon.